Hi students. So welcome to today's Brainiacs Capsule. Okay. So we have today the last session on ozonolysis. So I have taken some important questions, a little bit tricky but very important questions for this year's NEET exam. So I hope all of you would enjoy it. Okay. So the question here is, okay, I hope you could see the question very clearly. So the question here is an alkene is there. Okay, an alkene A. This contains 3 CC bond. Okay, 8 CH sigma bond and 1 C comma C CC pi bond. Okay, and this alkene A on ozonolysis gives you 2 moles of an aldehyde having molar mass of 44. Which of the following is the IUPAC name of this particular alkene A? Okay, so you will get an aldehyde which is having a molar mass of 44 when you do ozonolysis of any of these 4 compounds. We don't know which is that. Okay, so let's try to find it out. So we have first one, but-1-ene. Okay, so we'll take, these are the clue that is given here. So this alkene, okay, it's given very clearly, an alkene A contains 3. So this is the description of the alkene. Alkene contains 3 CC sigma bond, 8 CH sigma bond and 1 CC pi bond. So it's not easy like you draw the compound and count all the things. Better we will try to do the ozonolysis and find it out. And what is the product you are getting? And another important thing is this A here, if you see, should be a symmetrical alkene. Why? Because you can see here they are not telling it's a symmetrical in the question, but how to find out that we will see that. Okay, so first we are taking but-1-ene. Okay, so if but-1-ene is taken, I can say if you are doing ozonolysis, you are getting propan-1-ol and formaldehyde. So here you can easily see you need to get an aldehyde of molar mass how much actually, and they are telling very clearly 2 moles of an aldehyde. Understood? So 2 moles of an aldehyde of molar mass 44. That is the clue. So that means you are getting 2 aldehydes having similar molar mass, means that alkene should be symmetrical in nature. Because if an alkene is symmetrical, then only you will get similar compounds on ozonolysis. That is why I told that is indirectly mentioned. The alkene is symmetrical. Okay. Okay. Now let's see, but-1-ene is unsymmetrical because you know. Okay, these two halves are not similar. Now we say but-2-ene. Now I can easily say this is symmetrical compound, but we need to check you are getting similar compounds, that is ethanol here also ethanol on ozonolysis. How to do ozonolysis? Break the pi bond completely or remove the 2 double bonds completely and put oxygen on both sides. So you will get CH3CHO, here also CH3CHO. Now if you calculate the molar mass of this one, 2 carbon atoms are there, so 12 into 2, and 4 hydrogen atoms are there, so 1 into 4, and 1 oxygen atom, so 16. So you are getting the molar mass as 44. So from this itself I can say my answer is which one, sir? I got the answer, that is but-2-ene would be my correct answer. Clear? So in this question, it's why it is tricky, because they have not told this is symmetrical directly. Instead, they told you get 2 moles of an aldehyde of molar mass 44. They are also not telling you are getting 2 similar aldehydes. Instead, they are saying you are getting 2 moles of an aldehyde. Both are having molar mass 44. So that those 2 aldehydes can be of similar nature or dissimilar. But since molar mass is same, I hope it should be the same one. Okay. Now if you have doubt, you can try out the other one also, pent-2-ene. Easily I can say this is unsymmetrical, so you will get 2 different aldehydes. Whenever you are getting 2 different aldehydes, you can see here, this is pent-2-ene, 1, 2, 3, 4, 5, pent-2-ene. So if you do the ozonolysis of this one, what you are getting, sir? You can easily see oxygen on both sides distributed. So one you are getting ethanol, but the problem is the other one is propanol. So one is 44, but the other one is not 44. Now next one, but-2-ine. Now this is one important thing, because until now I haven't taught you how to do ozonolysis of a alkyne, but the trick remains the same. What you need to do, whenever you see ozonolysis, you break the double bond. You break the double bond means you break 2 bonds from that. So 2 bonds are broken from here, means what? You will get a CC single bond here. Correct? So if you break 2 bonds, or double bond should be broken. Double bond should be broken means 2 bonds should be broken. Then what will happen? This double bond will come here and double bond will come here. So you are getting a diketone. Okay, you are getting a diketone. That is what you will get for ozonolysis of alkyne. I can show you similar examples if you need. Maybe I will take some other examples also for you. Maybe if I am doing, let me say, ozonolysis of, okay, let me say some other alkene. Let me say CH3, okay, C triple bond CH. If I am doing ozonolysis of this one. So can you tell me what you are going to get? What you need to do? Tell me, sir. You need to break the two bonds. That is, always break double bonds while doing ozonolysis. So break the two bonds, there will be single bond between these two, put oxygen on both sides. Okay, so what you will get? CH3, tell me, sir, then C double bond O, then single bond oxygen is added to the CHO. So you are getting, either you can put it like C double bond O H, that is CHO. Okay, so you are getting an aldehyde along with a ketone this time. Understood? So very simple. Doing ozonolysis is very simple. Break the double bond and put oxygen or distribute oxygen across it. That's it. Okay, so when it is an alkene, the bond will completely disappear between the carbon and carbon. But if it is a triple bond, one single bond will remain between this carbon and this carbon. Clear? Yeah, let's go to the last different type of question. Okay, this is the last question from the topic ozonolysis. Here it's totally different. You are given a compound itself, a single compound of the structure. A structure is given of the structure. Okay, is obtainable from ozonolysis of which of the following cyclic compounds. So if you do ozonolysis of any of these cyclic compounds, you should get this particular structure. Okay, now this question you can logically do it. How? Because just think about, I will tell you two shortcuts. Okay, one is you do ozonolysis of all these cyclic compounds, you break it across the, put it oxygen across that and do it. That is one normal method that we have learned until now. But you need to take all the four options and do it. So minimum it may consume 2 minutes. But the easiest method is you take the product itself. For example, this is our product given in the question. So how to form the compound from the product? I will tell you the easiest way. First thing is remove the carbonyl oxygen. So this is our added oxygen, because during ozonolysis only we are adding this oxygen, correct? So remove the carbonyl oxygen. This you need to remove, this oxygen and this oxygen. Okay, so I have removed that. You can see here now double bond is only left behind. Then what is the next thing? Connect this carbon and this carbon via double bond. That's it. That's it. Connect the two carbonyl carbon using double bond. So I have connected here. So this one I have connected all the way to here. Okay, so you will get a structure like this. You can see here. This carbon I have bended and connected like this. Now from the options, this is the compound I need to identify. For this compound on ozonolysis, I am getting that product. Now from the options, I can see here how to identify it. You can see, you can just number it. Okay, so while numbering, I can say 1, this should be 2, this should be 3, this should be 4, and this should be 5. So I can easily say in the first and fourth position, you have methyl group out there. So from the options, I can easily say first, so this is 1, this is 2, this is 3, and this is 4. So in the first and fourth options, you have methyl group. So from this one, I can easily say my answer here is, which one, sir? Option 4 would be my correct answer. Clear? So there are two ways to do it. One is doing ozonolysis of all the 4 compounds. That may consume a lot of time. But the other way is take the final product. Okay, take the final product, remove the carbonyl oxygen. You can see you are getting, and connect the carbon this one and connect the carbon 2, which is having the double bond. You connect these two and you will get the structure. Just number it and identify the correct compound from the options. Clear? So I hope you have enjoyed today's session on ozonolysis, and I hope all your doubts on ozonolysis got cleared. Okay, so if you have any doubts, feel free to put it in the comment box. And those who feel like, okay, sir, I would like to do an offline course, you can directly contact Brainiacs Classes. Okay, we are here to completely help you to crack NEET 2024. Okay, thank you. Have a great day.